Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at unshielded twisted pair cabling, also known as UTP. We'll be discussing the properties of UTP cabling standards and connectors, straight through and crossover cables. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. Now, there's several properties to this unshielded twisted pair cabling. If we notice, there's 8 wires in it. 8 wires are typically twisted in pairs, and so a lot of people will call this 4 pair of wires, or 4 pair. Instead of 8 wires, they'll call it 4 pair. The wires are color coded in such a way that makes it easily identifiable on both ends of the cable. The 4 main colors here are orange, blue, green, and brown. Now, there's 4 wires with the orange, green, blue, and brown, and then the other 4 wires are basically a white wire with the stripe of the main color, and then we wrap those two together. So we have an orange wire and a white wire with an orange stripe, and we wrap those together. And then a blue wire with a blue stripe, green with a white green, and a brown with a white brown. We get those, and what's nice about it is on one end of the cable, the orange cable or orange wire is the same as the orange wire on the other end of the cable, whether it's 2 feet long or 100 feet long, easily identifiable. One of the things that we do with the unshielded twisted pair cabling is we twist them together, and that gives us some cancellation of that interference. If we look here at this, notice how this wire is twisted. This is one full twist of the blue wire. So we twist it here, that's halfway. This is a full twist. Now let's look at the brown wire. The brown wire, we'll start right here. We twist it, this is halfway. We twist it again, this is a full twist. This distance is bigger than this distance. And that's what makes the difference in some of the cables is how that twist is. And notice, these twists not only eliminate crosstalk between the pairs of wires, between the blue and the blue-white, but it also eliminates crosstalk between the pairs of the wires. And so there's a lot going on here. And once again, the engineers here at IEEE, they came up with the solution. They figured out which is the correct twist pattern. How many twists per foot does the blue wire get compared to the orange wires, compared to the green wires, compared to the blue wires? And if we control that, it eliminates a crosstalk. If you eliminate the crosstalk, less interference, more throughput through. Now, there's cabling standards out there for this unshielded twisted pair. We started off with Cat 1, Cat 2. We really don't talk about those. Cat 3 were just wire, basically your 8 wires were ran through the cable straight. There was no twisting or anything like that. And then Cat 4, I don't know what happened to Cat 4. Nobody ever really heard of it. Then we have Cat 5, Cat 5e, and Cat 6. Cat 5e was really one of the first standards out there. It gave us a speed of up to 100 megabits across that wire. And for the time when it came out, it was lightning fast. And we can see that there's different twists here on this. Once again, the blue is, this is a full twist in blue. This is a full twist in brown here. Here's the green. Full twist. Here's an orange full twist. So they're all in there with different twist rates. And that was what made Cat 5e be able to go up to 100 megabits. Then Cat 5e, 5 Enhanced came out, and what they came up with is if we control the twist better. Now, when Cat 5e came out, when Cat 5 came out, the number of twists per foot, per distance, it was, you could do like 12 twists per foot. That's not right, but let's just say it is. And they gave you and said, let's do 12 twists per foot. What Cat 5e did say, okay, we're going to keep the 12 twists per foot, but you can only vary it by plus or minus 0.001 twists. And so it became much more stringent on the specifications, on the amount of twists. Not only the twist per pair, but how the twists were located among the other pairs. If you slid one pair of wire up a 1/4 inch or down a 1/4 inch, it had an effect on the amount of throughput you could get through your wires. And so the engineers figured out, if we position the different twist rates at different places in the wires, we can get a higher throughput. And that's what allows Cat5e, the controlling of the twists on the pairs, and then also the relationship of the pairs to each other, that allows them to go from 100 meg on Cat5 to 1 gigabit, 1000 megs on Cat5e. Now Cat6 takes it even a step further. We're going to control the twist even more. We're going to, instead of allowing you to have 0.00 variation in your twist from Cat5e, we're going to allow you to only have 0.0006 twists per inch. A much smaller variance. And then they also added in this plastic insulator here in the center. You have this plastic insulator, and what that is if you look at the end, it's like a cross, and each pair of wires sits in a quadrant. And they figured out, if you separate the pairs by just that little bit, that even increases your efficiency more, and you can get a higher, more reliable throughput through there. And so as we see from Cat5 to Cat5e to Cat6, we're getting higher speeds, but we're being more stricter on the controls on our wires and the twisting them together. Now, I know some of you are going to say, what about Cat7? And there's Cat7a and there's Cat8 out there. Well, Cat7 and Cat7a, they sell cables to these standards, but these standards were never approved by IEEE. It's not an open standard. It's actually a proprietary standard to a certain company. They came up with these standards. They own the patents to them and stuff like that. Cat3, Cat5, Cat5e, Cat6, those are all open standards developed by IEEE. Anybody can use them. Cat7, Cat7a, you have to go to a certain company, pay a license, and do that. And because of that, not a lot of companies went and got or produced Cat7 and Cat7a stuff. A lot of companies are going into Cat8. Category 8 cables. And what that is that's another standard developed by IEEE, open standard, so you don't have to pay a licensing fee, and it's a little bit faster and a little bit more stable than the Cat7. And the big thing about this is the pairs are individually wrapped, and the specifications are really, really minute for this. The pairs are wrapped, and we can get higher transfer rates. We can get 10 gig, we can get 100 gig across those connections. So we do have these standards coming at us soon. We do see Cat8 in data centers now. Data centers where we have to transfer data between your database server and your manufacturing server or whatever it is. We do see Cat8 connections there. Right now, that equipment is really expensive, but pretty soon we're going to see it be cheaper and then more common to us. If you like this episode on unshielded twisted pair cabling and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now, for unshielded twisted pair, typically the connector here is what we call an RJ45. That's a specification made up by one of our standards organizations group, and it specifies all the different things about these little ends here. It specifies how wide it can be, how tall it can be, how long it can be, the spacing between these little copper pieces in here, how far they can be, how long can they be, how deep do they go, what kind of connectors do they need to go into the wire. And so we have all these different, each little thing here is a different measurement in that specification. We have the connector that has this all set up. We have the socket down here that the connector goes in. And those are like wall plates or ports on a router or a switch. There's all sorts of specifications for that. Once again, how wide it is, how far apart these wires are all placed in here. And so we have all of these standards set up for us, and it's the RJ45. We thank the people who came up with it. We just know we have to use RJ45s. Now, I do want to mention something here about good cables and bad cables. If you make your own cable, notice here that this one is poor, and by poor happens right in this area. The sheathing, the green part right here, is not caught into the cable. Now, what that does here on the bottom, notice how the green goes all the way up in here, there, and then it's locked in here when you crimp the tool. And what it does is when you lock this green sheathing, the outside covering, into there, that makes it more stable, more firm. It doesn't break easily. Now, take the top one where we have that gap right here. And so now it can easily flex. That plastic sheathing isn't doing its protection. And when you flex it, and what happens to a wire when you flex it up and down and up and down, it's going to break. And so that is bad. So if you ever make your own cables, please make sure you get your end in here all the way up as far as you can go, and it's caught by this little crimp here when you do that. You have the RJ45. You have your unshielded twisted pair. You have to put the wires in there. And there's two standards on which in which these can go into. And they're identified by typically their names, the T568A and the T568B. They're identical. They use the RJ45 ends, but it's basically the order in which those wires are put into there. The T568A comes from a long time ago when Ma Bell, the telephone companies, they were doing all the cabling and that type of stuff. That was their standard. Well, of course, we didn't want to do what the big phone company was doing. We wanted to do our own. So as networking sort of grew up and we were rebels, we came up with our own standard. That's where T568B is. And so we have two standards out there. Which one do you use? Well, it really doesn't matter. What matters is what you put on the ends of your cable. Now, on a straight through cable, you want to put the same on both ends. So you want to put the T568A on one end, T568A on the other end. That gives you a straight through cable. And once again, straight through cables, you connect between like a PC and a switch. If you want to do a crossover, what you do is put one standard on one end and the other standard on the other. So on the cable, you'd put a T568A on one end, you'd put a T568B on the other end. That crosses them over. That crosses the communication. That makes a crossover connection. And once again, we use a crossover cable when we're connecting like devices. Switch to switch, router to router, PC to PC, server to server, except for one place. When you go between a router and a PC, or a router and a server, a router and a computer. When you go between a router and a server, you have to use that crossover cable. So crossover cables, once again, are for like devices. Router to router, switch to switch, PC to PC, except for router to PC. Now, some people consider the rollover cable legacy because most Ethernet ports nowadays, they do what we call auto MDICs. They auto sense what type of cable you need and automatically switch to it. So if you give them a straight through cable and they sense, hey, this is a PC to PC connection, one of the ends will switch to the other one, giving you essentially the correct cable in there. So some people consider it a legacy, meaning we don't need it anymore, but there's still situations in this world where you need it, and in this course we're going to continue to emphasize where you use the correct cables. It was my pleasure to provide you with this wonderful episode on unshielded twisted pair cabling. If you like this episode and you got value of it, and of course depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.